afternoon and welcome to our 21st annual exhibit of hydrogen and fuel cell technology. We've been here for the past 20 years, since 1995, discussing this technology. It's always interesting to see where the developments are. One of the issues in development, of course, is the question of critical mass, how much cooperation it takes. The more difficult the market is, to break into the market involves, of course, networking. And we are privileged to have today a group of people who work in such a network and who see the value of cooperation, not only here in Germany, but in order to address the export markets, which is a big question we'll be talking about. It is, after all, a fair in cooperation with the United States this time around. To go through the order of my guests, I'll be talking with Lukas Rohleder, who is the Managing Director of Energy Saxony, and that is the networking organization he will describe in detail. Next is Andreas Frummel, and he's the Vice President of Business and Commercial Development at Fuel Cell Energy Solutions. And last but not least, Karl Benninghausen, who's CEO of Sunfire. Sunfire has a large stand in this direction. They belong to us, but they also have their own format. I mean, it's the privilege of success, I suppose. But let's roll back and start with Energy Saxony, which really is something that has been developed specifically to address the necessity of think tanking, of coordinating efforts. How did Energy Saxony evolve? How did it start? Whose idea? And where are you now?
Sure. Thanks a lot for that, for the kind introduction and for having us here today. Let me briefly tell you what Energy Saxony is about. The Free State of Saxony is well known for its automobile industry, for one thing, and maybe also for the microelectronics. But what we have really developed in the last 20-something years is a state-of-the-art know-how in terms of energy technology that spans the entire spectrum from the research and development through production to the end user. And certainly one of those key issues are fuel cell technologies, where we specifically around Dresden have a really important footprint in terms of research and industrialization. So what we have come to understand is that as a state, we would like to showcase how the solutions for the energy transition can come into market. And so this spans, as I said, further than fuel cells, and that's why within our network we're combining know-how, for example, in terms of resources or climate and so that's heat and cooling, and lots of other different issues. And what makes us strong is that through the combination of all the players, we can establish projects, and we come together at places like the Hannover Fair to really showcase where we stand right now. And altogether, just to give you a number, we are more than 60 organizations throughout the entire state of Saxony, and we work hard to get those technologies that are developed in Saxony to the market.
And just an indication of some of the bigger players, who are you partnering with? Who's involved?
Well, you can see the big players here on stage with us, Sunfire and Fuel Cell Energy Solutions, and my colleagues will give you a very good overview of what they're doing just later on. And but you know, all the Fraunhofer institutions in Saxony, the TU Dresden, University of Leipzig, all the others are on board, and I think we have a lot to show, and we'll tell you more about that, but also come visit us at our stand just back there later on.
B40.
Exactly.
Right at the back. Andreas Frummel, I like to talk to people who say commercial development in business, because we are not all products of subsidies. These technologies are increasingly marketable. You particularly focus a lot on stationary applications.
That's right.
And your take on that is molten carbonate, not the solid oxide.
Not only.
Mm-hmm.
So we are a joint venture of Fraunhofer, KTS, and Fuel Cell Energy in Danbury in the US, and this is the largest fuel cell company in the world with right now 600 employees. And we have indeed the MCFC technology, which is suitable for large stationary fuel cells, up to several megawatt. The largest installation is 60 megawatt in South Korea. And we also have the SOFC, reversible, also to use that to store energy in hydrogen. And we are producing with our MCFC technology also hydrogen out of natural gas, and we could use this same MCFC technology to capture the carbon out of the exhaust streams from steel industry, cement industry, to use that for instance, chemical processes. So we have a large range of applications. Mm-hmm. But of course, our first focus right now here in Europe is to develop the stationaries, especially with the MCFC technology, because we are a kind of success story between development in the US and in Germany, always 20 years, like the exhibition here. Mm-hmm. And now we are combining that during the last 3 years. And in Dresden, we are developing the next global cell generation, which should have a lifetime of 7 years. We are really with open books combining US experience and German experience to have both the best things together to develop the next state of the fuel cells.
And of course, whenever you hear the next generation, one has to ask the question, what's the older generation and what is the next generation? Is it simply the lifespan issue that you have addressed? That is, your new generation of fuel cells has a longer lifespan? Is it efficiencies? Is it the specific application it's developed for? Or is it easy to name?
Thank you for the question. I would say we are commercially ready, so we have more than 100 plants running in the field, produced till now 4.7 terawatt hours electricity, clean electricity. It's not anymore a question of efficiency and things like that. We have to come down with the cost. Mm-hmm. And longer the lifetime means exactly coming down with the cost, because we don't have to replace a stack after 5 years. With 7 years, you have 40% longer lifetime, which brings down the operational cost in that case. Mm-hmm. So starting in a niche market, to have a market deployment, you could use different ways, and with every cost reduction you would open the way for the next niche and probably for the mass market as well. Mm-hmm. But it's also a question of the right regulations and policy in place, supportive, not money, maybe using the advantages of the stationary fuel cells, which provide less harmful emissions, almost no SOx, NOx, which is acid rain and cancer. Mm-hmm. So this would help us to reach the mass market deployment. Mm-hmm.
Carl, when we were preparing our talk, we got on the topic of fuel storage, and then suddenly you said, just a minute, I don't want to talk about fuel storage alone, it's too narrow. It's such a huge issue, but in a transitional phase, there are a number of issues. So perhaps you could give us a broad indication of Sunfire's activities in the industry. I know you also work on a unit that does things in both directions. That is, it creates the hydrogen and it allows you to convert it back into electrical energy. So what's the spectrum of activities at Sunfire?
The core idea of Sunfire is that we want to transfer energy from one state to the other, from electricity to gas or to liquids, or from gas to electricity in the most efficient way. Because the conversion of energy, I think, is a key issue if we want to really do the Energiewende. And the most familiar concepts is fuel cells and electrolyzers. So we are doing partly similar things like fuel cell energy, but we are using a different technology base, which is the solid oxide cell. And the solid oxide technology is what Sunfire really does. We develop and we produce solid oxide stacks and systems, which are used then either in the electrolyzer, which is taking electricity, creating chemical energy, fuel, hydrogen, or if it's running backwards, it will take gas and efficiently convert that to heat and power, which is basically the idea of decentralizing our generation and to go from single generation to co-generation. the same technology can be used in so many different fields that you can get totally crazy. But we have, on the one hand, to industrialize this technology, which is probably very helpful in a lot of applications. That is our core mission. And on the other hand, we have to focus and to stay with what we can cope. Our company is now not a startup anymore. I would say we are now 90 people. We are also, like you do, really pushing industrialization, because I think that's really what's missing in this area. We need no better ideas. Fuel cell already and electrolyzer is better than whatever conventional technology there's around, but we need to industrialize, and that means we need to bring the cost down. So we have cost curve management as one of our issues. We need to be ready to deliver if things go wild and then the market blows up. We need to deliver, and we need to prove the reliability. That's what we are for. Now, Sunfire is based in Dresden. We are now 90 people, as I said. Our shareholders are one half private entrepreneurs, so we still have our entrepreneurial spirit. I'm one of those. And the other half is corporates. That's Total, that's EDF France, and that's ČEZ. So we do have the corporate reach, and we do have the entrepreneurial spirit. And I think if you visit Sunfire, you will see that people there, they like what they do, they laugh a lot, they have a lot of fun, and they do a really great job.
Mm-hmm. It sounds like engineers, right? They do have a lot of fun. Okay, just to get a historical panorama, things have changed. If we were sitting here 20 years ago, we would have engineers on the stage, largely very few businessmen, who all were fanatically in love with Robinson Crusoe, the novel from Defoe. When I say that, what I mean is you have the scenario of an island and someone stuck there who wants to use his mobile phone. So renewable energy, there is a source, there's either sun or there's a wind turbine, and you can store it in hydrogen, you can use it. This is a wonderful scenario because all of the details are calculable. And the issue that I find so interesting in commercialization is you have to recognize the fact, first of all, that we do have affordable fossil fuels, which can be used more cleanly. Okay, this is, for me, because we got into this discussion, this is why energy storage is sort of, is that the complete picture, just using the source of renewable energy and electrolyzers? What do you do with the hydrogen? But at the same time, both of you work with technologies, and many of your partners work with technologies that use far more efficiently natural gas, which is already a way to reduce emissions. So you're a businessman, among other things. Where do you see the next development? We waited a long time for the country Germany to turn into that island, Robinson, with only pure technologies. But the transitional period is going to be more subtle. It's going to be more dynamic. It's going to involve a plurality of solutions. So what solutions? What's going to come first?
Well, that's maybe my two colleagues will go into the details where they want to develop. You know, we are laying the groundwork for people to come together, to network and to come up with project solutions, and it's among the experts to really find the way forward. But as you said, I mean, the island solutions is something that it has always been on the agenda for fuel cells, and critical infrastructure is another development. You name it. It's data centers or hospitals, for example, they all can rely on fuel cells. But what I wanted to add is that we see those companies evolve now, and what's supporting that is the environment that we have in Saxony. And we as a network, we are trying to not only bring together the people, but to also find project finance, which is essential for a lot of those research institutions and small and medium-sized enterprises. So we're looking at where to get partners and where to get financing from all levels, European, federal, and state level. And just to name one real good example is the German Federal Ministry of Economics has come up with a large funding project called Integration of Renewable Energy in the East German electricity grid. It's called Wind Node, and out of those 40 million euros that the federal government is spending, we managed to bring more than 9 million to Saxony, to our partners, which are now proving that they can use their technology to run the grid more efficiently, to integrate a higher percentage of renewable energy, and a lot will come from that in all of those different areas, even with heating and cooling being a major issue, which is far too often neglected. We're always thinking about electricity, but heating and cooling is a large part, and we can go into more details that. But to stress the point once again, to have access to those funding opportunities is difficult sometimes for organizations, and we try to support everybody who does not have sufficient access yet. So that's one of our things we do. But maybe you would like to add to the point where the next evolution is coming from.
I think we should not ask for the next application, replacing every others because it's the best, and difference to the years in the past. There was sitting someone here, my fuel cell, my technology is really the best one. No, I think we have to rethink the total thing, the total situation, because if you remember your first email or your first website you visited in the 90s or maybe earlier, and then there was a conversion that everyone thought in the classical business, oh, I think internet is important, we should deal with that. And I would say today we are in a situation that the classical business is thinking fuel cells might something we have to deal with. Let's talk about that. Let's think about how we could integrate that. And we should not fight against the other technologies because we will have a mix. The fuel cell is in a great situation that the fuel cell is a bridge between the sectors, between energy production and consumption and vice versa. The fuel cell is the only tool which produces their own fuel. So I could take the sun and produce hydrogen, and later on, if there's no sun, I can use that. So I think we are in a transition that there will be energy landscape with a lot of fuel cells. The question is not anymore if, the question is who will deliver that. Mm-hmm. Will we buy that in the US? Will we buy that in Asia or in Europe or in Germany? Last thing to that, with the fuel cells, especially with this connection, the bridge between the sectors, we add to the energy landscape flexibility. And this brings us in the position that we could solve the issue with the renewables, the fluctuation, in a distribution net and not delegate that to the transmission grid and to the other location. So we could use all these flexibilities on-site, decentralized, and there's also a rethinking what we see. We installed the first megawatt fuel cell in Europe, and there's an industrial manufacturer using that. So it's a huge responsibility for us because his production relies on that. And we see also a transition that data center, for instance, take the fuel cells as a primary energy source and using the grid as a backup. So really a rethinking of all the things. And I guess that's the situation we are in. Not a new application, a new energy landscape.
Mm-hmm, mm-hmm. And of course, both of you are involved in the American market, not simply the German market. That always raises the question because markets are so different in terms of how to enter them. If you have a small community in India with no grid, you're dealing with a solution that is easier to calculate. The German market is incredibly stable. There are areas in the United States where sensitive technologies in an environment where there are brownouts and sometimes blackouts mean that the more sensitive the electronical technology, the more necessary it is to have an absolutely reliable either primary source or backup source. Do you see differences in terms of marketing when you compare the European, the German, and the American market?
Certainly there are. And I mean, the Americans are very close to us in the business culture. They are close to us in the terms of the maturity of technology, supply chain. So there's a lot of similarities, and that's why we can team up very well. but the business case and the requirements in the United States and in Europe are totally different. The grids are totally different. The existing infrastructure is totally different. And the political background for new technology is different. So we need different business models. And that's why I think a partnership between a technology company based in Europe like us and one of our large partners is Boeing, for example, in the United States. That's a very helpful thing. On the technology side, we can help each other, and we are doing projects with Boeing in Europe, and they are doing projects with us in the United States. But we need people there to understand the economics of the technology, and that's I think that's the core issue of the whole thing. Because if we want to be successful, we have to understand the economics and the business cases. When Sunfire was starting, we were a very small group of crazy people with this idea of creating fuel from electricity. And in order to become real, we had to buy other companies with existing technology. And the first company I bought was Staxera in Dresden. They were producing stacks, and they were brilliant engineers, and they had done a terrible job a terrific job on the solid oxide. And when I came into this company, I said, well, guys, what you're doing is great, and I will learn a lot from you, but please, you have to learn also something, and that is understand your technology and describe your technology not in kilowatt hours, but in euro. What is going in? What is needed in the process, and how long will it last? And what is going out? All described in euro. And then, if you have a solution which is still better than something what others can do, even if you look at the euro and not at the kilowatt hours, then we win. Yeah, and this is the same thing why America and Germany are maybe a little bit different, because something that might work here might not work there, and the other way around. And if we understand where do we really bring economic value to our partners and our customer with this technology, there we do have the niche, and there we do have to focus. We do that in a very specific way because Sunfire is still small. I mean, for me, 90 people is already very many, but compared to what we have to do, it's not very many. So we say, to develop a market, to do the service, to do the certification, to do the balance of plant, to do the sales, that's all done locally. And we are always teaming up with large players. We do that with Boeing in the United States, with China Steel in Taiwan and China, with ThyssenKrupp in Germany for ship industry, with Weiland for the heating industry, and with Gazprom in Russia for pipeline power, and so forth. So we have large partners, and we share the value, we share the profit, we share the know-how and the technology. We always focus on what we can do. That's the core assets, that's the solid oxide system. And then we have the totally different applications and business models and the totally different economics. In Russia and the pipeline, it's totally different rationale behind why would you use a fuel cell than, for example, in the United States, when Boeing is using that technology for a 24-hour, 7 days a week availability of power in a Navy environment where they just have fuel, solar. Yeah, it's totally different, and we need those partners, and the United States is a great case to collaborate on that way.
When I think back, there have been some interesting energy budget changes. Certainly, Germany has always used natural gas for much of their home heating and heating their water. It's not always the case in the United States. But the interesting thing for me is that the United States has become a large natural gas producer relative to where it was when we started here 20 years ago. Has this affected the development side? Because let's face it, when we talk about the purists who want to use renewable energy, sun and solar for hydrogen, that's one scenario. But the other scenario is Germany's energy budget does rely substantially on natural gas. And people, I assumed, 15, 20 years ago, we're thinking of the first stationary applications as a better way to use that non-renewable resource here in Germany. All of a sudden, that equation works in North America. The more they use natural gas, the more the question occurs of why not use a better technology to access the energy within that natural gas. Has that changed the thinking within Energy Saxony, and has it changed your business models a bit towards the American market?
Well, the thing is that the great opportunity of fuel cells is that you can have many resources, and it's a great way to go into the market to industrialize your scale and to really bring that up, and you can use whatever is cheapest, and certainly I suppose you have the better experience, but that it helps to have such low prices of gas in the US. Right now, but in the end, we're always trying to tackle market barriers. That's what it comes down to. How do we access the market? And the question, or what we're facing is we want to increase the share of renewable energy in Germany. You're totally right. We do rely largely on gas in Germany for the time being, and but that it cannot hinder the development. And if you have a technology like fuel cells to have the infrastructure in place and then just replace the fuel you're running on, that's the perfect way to go forward. But there are even more things to go forward. I don't want to go into the policy discussion too much, but there are two other aspects that would be really beneficial to increase the share of renewable energy, which is storage in general, which also our Free State of Saxony puts a lot of attention on to increase capabilities and facilities in that respect, and digitalization. Which is an important issue if you look at how can you shift your loads throughout the day to increase the share, and so that is another aspect that we're working on within our network, and talking again about market barriers, we want to go forward. We have we have been placed in the environment. It's been decided politically that we have the energy transition, and we think we have the capabilities to show that it's possible. But on the way, we are fighting those market barriers step by step, and certainly cheaper prices in the gas may be beneficial, even as odd as it sounds.
Andreas, has the market approved?
I would say our most challenging competitor is doing nothing.
Okay. Yeah.
Doing nothing, because I can relax. Gas prices are cheap, so I can consume as much as I want. It has less impact than in the past, and that's a challenge beside our technology and the market deployment, that people should not only think. So I'm a little bit. I want to mention that in addition to your comments, or euro in, euro out, because based on that, we are in a great position. We spare a quarter of the natural gas, which is necessary to make the same energy with different technologies. And as you probably know, the EU spends €1 billion per day to buy primary energy, to import. So a quarter is a lot. We could do a lot important things with this money. But we should also see that we reduce the harmful emissions.
Yeah.
And right now, in most of the states in the EU, this portion of the benefit of using this technology is not monetarized. Mm-hmm. So euro in and euro out might be challenging if you would compare the business cases, even if we have the low gas price right now. Based on efficiency, we would lower the cost for electricity. But if you would add the CO2 reduction, and if you would add almost no NOx and no particles, Feinstaub, then we would have a much better business case. Mm-hmm. And I guess we should really find ways to take that into account, either a penalty for emissions or a bonus for less emissions. Mm-hmm. And one sentence, the fuel cells, the stationaries and the mobile fuel cells, they are the technology to reach the highest possible share of renewables in the energy landscape, because we could leverage the renewables. It's a kind of leverage for the renewables. We could much more add solar and wind to the current energy mix if we would combine that with fuel cells.
Yes, I would say if there's cheap gas available, that's basically a good thing, because we want renewables, but we also want economic energy. And the Americans probably would go economy first and then renewables, and we would in Europe probably go renewables and then economy. But it's no matter how we turn it, if we are not economic, we will not prevail. And the idea is always coming from surplus energy to shortage, coming from low value or from cheap energy to high value energy. That's what we have to do. We have always to convert from low value to high value, otherwise nobody will do it. And if there's cheap gas and we can transform that to valuable electricity, great thing. Another thing is that gas is something that you can store in a tank, and somebody who is used to be off power all the time because the cable to his house is very long and it's obviously broken by storm or snow or whatever, he has some sort of backup anyway, and if he can then use a gas tank, and he knows the energy is sitting there, like you have a pile of wood in front of your house. Yeah, that's very nice. If you have gas there, it's reliable and it's already there. You don't have the cable, which is always vulnerable. And then people have a good economic by bringing cheap gas to power and heat, and also they have a more reliable on-site generation. That's a good thing, and we should take advantage of this, and we should support it.
I should add, if there are any questions from the audience, we do have time during the discussion. Just raise your hand. We do have one.
Great discussion, guys. So, quick question. As the application of the fuel cell changes from industry to industry, can you touch upon how do you design fuel cell to functionally fail, as in to fail safely? So that it's contained as well as there's no exposure to other industries. And my most interest has been in robotics.
What's robotics?
Robotics.
Robotics. Any takers?
You're looking to each other?
Yeah, just to really grasp the question, you are talking about the reliability and how we are making this industrial, or to...
Sorry, I rambled a lot. Just to clarify, I'm interested to look at fuel cells in mobile robotics. With that application in mind, please explain how do you make design choices so that the technologies fail safely, and how does the reliability doesn't get impacted?
That's an interesting question to people doing stationaries.
Yes.
So, I personally have no clue. I would answer to this subject that we, of course, since we are trying to supply baseload power or primary power to the customer, have a strong focus on reliability. So, not to go into the details, the result is that we did a neutral investigation, and we observed 50 of our plants, and the outcome was that for the fuel cell we have a 98% availability, which is good, I guess. And then we are working, for instance, if we want to produce power for a critical environment like a data center, we would structure that we have redundancy in the fuel cells and their structure with fast switches and things like that. And that's the answer for the stationary part of your question. For the mobile, I think combining with a battery is a solution, but how we would design that, I guess you should search for the right booth here to ask that question. That's from my end.
Yeah, I would answer in a similar way. If you're talking about mobile robotics, that's probably very close to mobility, to cars. And the high temperature fuel cells, that's both what we represent here, is probably not the best options for mobility. At least they are not easy to for fast starting. Yeah, they need heat up time, and they are relatively large systems. So I don't know if that is really what you're looking for in mobile robotics. If we can apply the same idea to cars, and maybe you are talking also a bit about larger systems and systems who are working on a long-term or more continuous base, then it's a different story. And I would say there's a lot of analogy between those mobile robotics or devices and cars. And in cars, I always say the issue that we do have with electricity from batteries is that they have the loading cycle and the limited power range. And so it's probably always a good combination using the battery for the immediate response and for the short-term traffic, plus something which can then use stored sun power, for example, in the term of electrical fuels, and convert on board an additional energy stream if you go long term, if you go heavy duty, if you go for something which the battery doesn't carry. That might be the same idea for you. And the high temperature fuel cell, probably not the molten carbon, but the solid oxide might even be an option if it's a real long term operation and it's plannable, and if you need heat. Yeah. The batteries for the cars are good for the motor, but not very good for the heating of the car. So you need something to solve that that problem as well. So that might be the solution where we both meet.
That itself, the question itself addresses this inherent diversity at the fuel cell community here, and also some of the cycles. If we look back 10, 15 years, a lot of engineers with their toys up here, utility power units, and the first innovative hybrid devices, the forklift trucks. Now they're marketing these things as niche markets. I want to stress niche markets because in distinction to these niche markets, the example being a forklift truck, to tank that forklift truck, it takes you 3 minutes. To charge batteries, it takes you 8 hours. And it's an independent device. It operates wonderfully. There's already an existing financial market. These gentlemen here are addressing a nation's energy budget. Okay, so this is a question of scale, and the stationary applications really raise fundamental issues. We have only a minute left, but in this last minute, I want to take almost 20 seconds, which is ungenerous, I know, to address the final question. Thank goodness after the election in Canada, we actually have a government that is behind the reduction of greenhouse gases. There is a political impetus behind this as well. And these are very different in the United States, depending on where you are. Look at California with its incredibly progressive emissions controls. But there is another factor involved in this budget. We simply don't want to reduce only the consumption of natural gas. We have an environmental issue at the same time. If you go to fuel cells and hybrids, you can send trucks instead of diesel trucks within the center of Berlin. Right now, the European law says on certain days these trucks should not be operating in the city because of the emissions. So I guess beginning with you shortly, you get to use also the political side of that argument. It's almost a social side. It addresses the issue of future societies and whatever, but at the same time you have to communicate upward to the people who make the political decisions where this industry is. Is it easy to mediate that tension, to talk to inform those people who make the political decisions, and to make sure the people on the ground have the options available?
Well, the people on the ground are asking for the euros between the hands, and that is what it all comes down to. And in order to come to cheap renewable energy solutions, we need to have financing for industrial scale production. And that's just to stress that again, we are great on the research level in Saxony and in Germany itself. What we need is funding for the next steps for the implementation of demonstration and pilot plants, and we're working hard for that, and that needs to be provided, and that is a political question we need to solve.
Okay. Shortly.
Yes. How should I say that? We have a toolbox available today. So it's not hydrogen in the future, blah, blah, blah. We have it today and it is ready to go. So the question is awareness.
Okay.
So both the people on the street, if you would name that so, and the politicians should be aware of the tools and their use and the possibilities.
Okay. And Carl, one sentence to wind it up.
Yeah, I also think awareness is important. Either, first of all, that the tools are there, and secondly, that the risk if we don't use those opportunities are not only that we exploit resources which will be very necessary in the future, but also that if we exploit fossils, we have an impact on the climate and we will have an impact on energy prices, and both will not hit us by here in Germany. That will hit us because people in Africa, they will be deprived of their basis of living, and they will come here, and that is the real problem. Yeah, because if they have no, if their harvest is wasted, if they have no energy to bring their water to the people and stuff like this, that is where really the whole world will then collapse, and not because driving a car is more expensive. That's not the problem.
Okay, we'll have to continue the discussion at Energy Saxony, which is B40 back there. It's been a pleasure talking to Lukas Rohleder, who's the Managing Director of Energy Saxony, Andreas Frommel, who is the Vice President in charge of Business and Commercial Development at Fuel Cell Energy Solutions, and last but not least, Karl Berninghausen, who is currently the CEO at Sunfire, and his booth is in that direction. H25, I believe.
Somewhere there.
Yeah, somewhere there. Okay, it's been a pleasure. Thank you very much, and thank you for your attention. We'll be continuing. I have been outrageously long here, but take the next 5 minutes upstage. Next is Professor Anke Hagen from DTU Energy, and they'll be talking about Danish activities in solid oxide fuel cells. And we'll welcome Robin on the stage.
Thank you very much.